Hello students, welcome to CREST YouTube channel. So today we are going to discuss a very important topic from the organic chemistry of 12th grade, nothing but alcohol, phenols and ether. Ready? So let's go through the chapter. So first of all, I will give you an idea how we will introduce or otherwise how we will provide the entire chapter through our YouTube channel. First of all, we will provide the chapter in different part. In first part, we will discuss an introduction of the chapter, like how this alcohol, phenol, ethers are formed, okay, from hydrocarbon. The general introduction I will give you. Then after that, classification and nomenclature of alcohol, phenol, and ether. Ready? So these three topics we will discuss the part 1 of the chapter, okay, the session, okay. So after that, I will provide you the structural functional group, like what are the structural features of alcohol, phenol, ether, just like their bond angle, their bond length. These concepts we will discuss in part 2. Similarly, the method of preparation of alcohol and phenol. Ready? So these two concepts we will discuss in our part 2 of the chapter. Ready? So after that, in part 3, we will discuss physical properties of alcohol and chemical properties of alcohol, phenol. Ready? So both for both alcohol and phenol, we will discuss their physical and chemical properties in part 3. Clear? Ready? So in part 4, we will discuss what some commercial important alcohol, just like methanol, ethanol, how we can prepare these compounds, and what are the commercial applications, okay, that we can discuss. And similarly, we can discuss about what either the preparation of what either. So these two concepts we will discuss in part 4. Okay, ready? So finally, in part 5, we will discuss what the physical properties of either and chemical reactions, otherwise chemical properties of either. So these are the parts we will provide you. Through these parts, we will provide the entire chapter in our YouTube channel. Okay, ready? So we can start the session. First of all, in this first part, we can discuss the introduction of the chapter. Okay, let's start. First of all, uh, well, we know the concept of hydrocarbon, right? What is hydrocarbon? Compounds having both carbon and hydrogen only, right? So if I'm taking 3 carbon, you already know the concept. We have 3 hydrogen will be here. Here we have 2. Here we have 3 hydrogen. Okay, it's based on their covalency, right? Covalency of carbon, to satisfy covalency of carbon, we need to provide this number of hydrogen, right? Am I correct? Yeah. Okay. Now we can substitute this one of the hydrogen with other OH group. This OH group we can call it as hydroxyl group. We can call it as hydroxyl group. Okay, hydroxyl group. Okay, so by substituting one hydrogen of hydrocarbon with hydroxyl group, we will get what? Alcohol. We will get alcohol. It's simple, right? Yeah. So this one is, we can call it aliphatic chain. Aliphatic chain, okay, or otherwise we can say a normal chain of hydrocarbon. We are just changing one hydrogen of a aliphatic chain with OH group. Okay, so we can easily prepare what? Alcohol. It's simple. And similarly, we can consider an aromatic chain. Look at here. I'm just taking what? Benzene. Okay, we already know the concept that each carbon in benzene is occupied with one hydrogen, right? Am I correct? Yes or no? Yeah. So here we know the concept. The molecular formula of benzene is what? Is C6H6, right? That is benzene. We can call it as benzene. Okay, ready. So here I am substituting one of the hydrogen of benzene with OH group. Okay, we can substitute any of the hydrogen. Okay, now I am just substituting here one hydrogen with the OH group. Ready? Now this compound become what? Now onwards we can call it as phenol. We can call it as phenol. Got it? So you got the idea how we will get what? Alcohol and phenol from hydrocarbons, right? Yeah. Similarly, we can prepare what? We can prepare ether. It's very simple. Look at here how ethers are formed. Look at here. If we have a hydrocarbon, I'm just taking 2 carbon, like, so it will be like, we can consider it as CH3 ethane, right? Yeah. Now we can substitute one of the hydrogen of this ethane with alkoxy group. That's different. Okay, hydroxyl group means what? OH group, right? The OH group we can call it as hydroxyl group. Now what about alkoxy group? Look at here, the OR group, that we can call it as alkoxy. Okay, alkoxy group. Clear? So if I substitute one of the hydrogen with alkoxy group, I'm just substituting one hydrogen from this alkene. Okay, so not alkene, alkane, right? It's alkane. Okay, I'm substituting one hydrogen with the OR. OR means R group means what? What's the meaning of R group? Yeah, that's carbon chain itself, right? So you can take or just like I can give you some example here. Look at here. So it's we can call it it is either, right? This either we can call it as it is either. Now I'm ready to give you some other examples. Like look at here, just like if it is CS3 or CS3. Now here the R group is CS3, right? This R group, we can here the R group is nothing but CS3. Okay, so this is an example for you neither. Ready? So it's clear for you, right? Yeah, it's very simple. So that's the introduction part of the chapter. Now you got the idea how we can prepare alcohol, phenol and ether from different kind of hydrocarbons. Ready? Let's go for the next topic. That's nothing but classification of alcohol, phenols and ether. Can I start? Yeah. Ready. So first of all, it's very simple. Look at here. First of all, based on number of hydroxyl group, we can classify alcohols like mono or di or tri or polyhydric alcohol. That's very important. Polyhydric, monohydric, dihydric or polyhydric alcohol. I'll give some examples. Look at here. First of all, we can take an example like CS3OH. Ready? Here we have only one OH group, right? So now we can simply say it is monohydric alcohol. This is monohydric alcohol. Very simple, right? So similarly, if I took an example like CH2OH, CH2OH. Look at here. Here we have two OH group. Okay, in a single compound. So we can call it as dihydric. Okay, dihydric alcohol. These all are classification. Ready? Not IUPAC nomenclature. Okay, just simply these all are classification of alcohol. So alcohol having one OH group, that we can call it as monohydric alcohol. Okay, if there are two OH group, then we can call it as dihydric alcohol. Ready? It's very simple. Ready? So the I can give you one more example. CH2OH, CHOH. Here it is CH2OH. In this case, we can call it as what? Yeah, trihydric alcohol. Ready? Trihydric alcohol. Do you know this compound? Yeah, it's called glycerol. Or other ways we can also call it as glycerin. You know the compound glycerin? Yeah, we usually use to make cry. Am I correct? Yeah. So this is glycerin. Okay. Otherwise glycerol. We can glycerol for your knowledge. I'm just giving you the name. Okay, glycerol or the IUPAC nomenclature that we can learn later. Okay, don't worry. So now you got the idea, right? We can classify alcohols based on their number of OH group. It's very simple. Okay, so similarly we can classify phenols also based on the number of OH group like monohydric, trihydric. Okay, that we can do. So okay, wait, I can give you some example here. So look at here. In case of phenol, yeah, I can take another color. That will be better. Okay, yeah, look at here. If you have a phenol, okay, here we have only one OH group. This we can call it as monohydric phenol, or simply phenol, right? Yeah. So if in phenol if you have two OH group, just imagine two OH group, dihydric phenol. That's all. Ready? So that's it. I'm just giving you an example for what different type of classification of what alcohol and phenol. Ready? Okay. Now we can go to the second type of classification. Okay. So look at here. Monohydric alcohol may be further classified according to the hybridization of carbon to which OH group it has attached. That's very interesting, right? Look at here. Before starting the session, can I ask you one thing? Yeah, look at here. How we can understand the hybridization of carbon in an hydrocarbon or in an organic compound? How we can understand it? It's very simple. Look at here. You may know the concept, right? So still, I'm ready to explain here. Just look at here. Okay, if just imagine. Okay, you have two carbon. Both carbon are every bond in between this carbon or every bonds in the carbon is sigma bond. What is meaning of sigma bond? That is single bond, right? So if every bond is single bond, then we can call it this hybridization of this carbon will be sp3. This one also sp3. Okay, if there occur at least one double bond like this, look at here. Okay, if there occur one double bond, then you can call the hybridization of this carbon is sp2. This one is sp2. Clear? Now look at here. If you have an organic compound having a triple bond, okay, so the remaining covalence will be like this, right? Valence will be like this. Okay, so in this case, each carbon is sp hybridized. Each carbon is sp hybridized. Clear? Now another important and interesting topic. Look at here. If you have a carbon like this, okay, look, it's very important. That's why I give you in different color. Okay, so tell me hybridization of each carbon. Yeah, so here we have one double bond. Yeah, exactly. So it is sp2. Yeah, correct. So here also we have one double bond. Okay, so we can call it as sp2 hybridized. Exactly. Okay, but here, look at here. Here in this carbon you have 2 pi bond. Otherwise 2 double bond, okay, in a single carbon. At that moment, you have to know the concept. It's very important. The hybridization of this carbon will be sp. Okay, okay. So that I'm just giving you an extra point. Okay, just you can just note the point. It's very important. Okay, so look at here. Now we are going to discuss the first one. So on the based on we are just classifying these alcohols on the based on what? Based on hybridization of carbon to which OH group is attached. Okay, so first of all, the compound containing sp3 carbon, this carbon is sp3 hybridized, to which OH group is attached. Okay, shall we start? Yeah, so first of all, we can classify the organic compounds like primary alcohol, secondary alcohol, tertiary alcohol. Primary carbon that we usually represent 1 degree, right? 1 degree. Secondary, yeah, 2 degree, or tertiary we represent 3 degree, like this. Okay, so what is primary, secondary and tertiary alcohol? That we can discuss here. Look at here, you have a carbon, okay, to which this carbon is attached to only one carbon. So I can just give you one example. Look at here, this alcohol. Look to this alcohol. So in this alcohol, what is hybridization of this carbon? This carbon is, yeah, very simple. Look at here. So every bond surrounding to this carbon is single bond, right? So it is sp3. This is sp3 hybridized carbon to which OH group is attached. Ready? Now look at here. Here this carbon is attached with the only one other carbon. Okay, so at that time we can call it as this is primary. This is primary carbon. Okay, so this alcohol we can call it as primary alcohol. Otherwise 1 degree alcohol. Simple, right? Yeah. Look at here. Look at here. So you may have a doubt like, sir, if I have a compound like CH3OH, okay, okay, so this carbon is sp3 hybridized. Yeah, exactly. Okay, so what about this degree of this carbon? Look at here, still this carbon is attached with the 3 other hydrogen. There is no other carbon, right? Still it is primary. This is called super primary. Okay, primary alcohol. We can call it as primary alcohol. Got it? You ready? Yeah, and we can go to the secondary alcohol. It's very simple. Look at here. You have a carbon like this, a compound like, yeah, I can take another color, white color. So it will be like this. Just imagine like this. Okay, what about the hybridization of this carbon? Tell me. Yeah, it's sp3. So yeah, exactly, it's sp3 because here all bonds are single bond, right? Everything is sigma bond. Okay, so it is sp3 hybridized. That's okay. To sp3 hybridized carbon, this OH group is attached. Okay, so it is now we can look the carbon. This carbon is attached to other carbon. That's why we can call it as secondary alcohol. This carbon is secondary, 2 degree carbon, because this carbon is attached to 2 other carbon. So we can call it as secondary carbon. Okay, so OH group attached to secondary carbon, that we can call it as secondary alcohol. Got it? Yeah. Now we can go to the tertiary alcohol. Look at here. So this one, just imagine I have this alcohol. Ready? If you are filling the hydrogen, it will be CH3 CH3, here it is CH3, here it is CH3, here no need of hydrogen, right? All four valencies are already full, right? Filled. Okay. So what about the hybridization of this carbon? Yeah, that is nothing but sp3. Okay, every bond surrounding to the carbon is sigma bond, right? So what about the hybridization? Yeah, it's very simple. It's sp3. Then and what about the degree? Tell me, what about the degree? The degree is this carbon is attached to 3 different carbon. So we can call it as this is 3-degree carbon. So OH group attached to 3-degree alcohol, that we can call it as 3-degree carbon. Okay, 3-degree carbon, that is we can call it as 3-degree alcohol. Okay, OH group attached to 3-degree carbon, that is we can call it as 3-degree alcohol. Now you got the idea, right? So how we can classify 1-degree or primary, secondary and tertiary alcohols? Yeah, exactly. Okay, now we can go to the next topic, that is in the another type of classification, that is allylic alcohol. Remember, these all are coming from this point. Okay, compounds containing sp3 OH bond. The first one, primary, secondary, tertiary. That's very simple. Now we are going to discuss what allylic alcohol. Allylic means, look at here. Allylic means you have a carbon like this. Look at here. These compounds we can call it as allylic alcohol. How? Look at here. What's hybridization of this carbon? Tell me. So this is sp3 because every bonds are single bond. Yeah, exactly. So this is sp3. Obviously it is sp3. Okay. Now next we have carbon double bond. Okay. So what is allylic alcohol? If somebody asks you what is allylic alcohol, then you can suddenly answer like what? Allylic alcohols are alcohols in which OH group is attached to sp3 hybridized carbon next to what? Next to carbon double bond. Write the definition, you're not. Okay, so allylic alcohols are alcohols in which OH group is attached to sp3 hybridized carbon next to carbon double bond. Got it? Such alcohols we can call it as, we can generally known as allylic alcohols. I hope it's clear for you guys. Ready? Very good. Okay, so this allylic alcohol itself we can classify into primary, secondary and tertiary. Yeah, look at here, look at here. You have, I'm just taking the same example first of all. Okay, the same example, first one this one, and another one I'm taking this one, and the tertiary I can, everything is visible, right? Yeah, look at here. So first of all, this is allylic, this carbon is sp3, the same thing, right? So what about the hybridized, what about the degree of this carbon? This is 1 degree. This carbon is attached only with other one carbon, right? So this is 1 degree carbon. We can call it as 1 degree alcohol. 1 degree alcohol. This is 1 degree only, but it is allylic alcohol. 1 degree allylic alcohol. Got it? So what about this one? Here it is. This carbon is attached to 2 carbon. So it is 2 degree carbon, right? This is allylic only because next this carbon is next to what? Carbon double bond, right? So this is allylic only, but it is 2 degree allylic alcohol. Ready? Here also you can add what? Allylic. Don't worry. You can add here allylic. Okay, 1 degree allylic alcohol. Ready? And what about here? Look at here. In this carbon, the degree is 3 degree, right? This carbon is attached to, so 3 different carbon. So it is 3 degree allylic alcohol. Clear? Ready? So the allylic itself we can see in 1 degree, 2 degree and 3 degree. Okay. Now we can go to the benzylic alcohol. It's another type of what? sp3 carbon OH compound. Ready? So look at here. I will give you some examples. In case of benzylic alcohols, like it will be like this. Okay. So you have a benzene ring or aromatic ring. Okay. So next you have a CH2 group to which OH group is attached. Okay. So tell me how we can define this benzylic alcohol. Very simple. OH group is attached to sp3 hybridized carbon next to what? Next to aromatic ring or benzene ring. Clear? So such organic compounds we can call it as benzylic alcohol, or otherwise such alcohol we can call it as benzylic alcohol. Okay, this one itself we can classify into primary, secondary and tertiary. Yeah, look at here. I will show you. So first of all, if what about this one? Yeah, the same thing, the same one. Okay, here this carbon is 1 degree, right? It is attached to only one carbon. So here we can call it as this is 1 degree benzylic alcohol, 1 degree benzylic alcohol. Ready? Primary benzylic alcohol, we can also call it like that. Okay, and what about here? Here, tell me, is it 1 degree or 2 degree? Yeah, it's very simple. It is 2 degree, right? This carbon is attached to 2 carbon, so it is 2 degree carbon. So we can call it as 2 degree or secondary benzylic alcohol. Very simple, right? And similarly, if I'm taking another example, yeah, the tertiary one, I'm just taking here. Is it okay for you guys? Yeah, the same thing, right? Yeah. So look at here. Here it is. This carbon is attached to 3 different carbon. So this carbon is 3 degree carbon, right? So the alcohol we can call it as, we can classify it as 3 degree benzylic alcohol. Now you got the idea, right? How we can classify the benzylic alcohols. Okay, now we can go to second type of classification, that is compound containing sp2 carbon and OH bond. Okay, here we have only one type, that is vinylic alcohol. Yeah, look at here. The vinylic means, look at here, you have a carbon-carbon double bond to which OH group is directly attached. So you already know the hybridization of this carbon, right? What is hybridization of this carbon? That is sp2. So the same concept, right? sp2 carbon OH bond that you can see here. So what if somebody asking what is vinylic alcohol, then you can easily answer that point. What vinylic alcohol? Tell me. Vinylic alcohol is alcohol in which OH group is directly attached to carbon-carbon double bond. Okay, ready? So now we can discuss what classification of phenol. Okay, so in classification of, I already mentioned some examples like monohydric alcohol, dihydric alcohol, trihydric alcohol in the beginning, right? Similarly, we can also classify phenols. Okay, similar to that of alcohol, we can classify phenols. Like this is called monohydric. This is monohydric phenol, simply phenol itself, right? Here we have only one OH group, and we can also classify this one also as, look at here, you have CS3. This, if we have CS3 in your benzene ring, that we can call it as toluene, right? Yeah, similarly, if there is one OH group, okay, in this case we can class. I'm not going to discuss IUPAC nomenclature, that we will discuss later, okay, this section itself, okay. But here, look at it, we can classify it as, here we have only one OH group, we can call it as monohydric, okay, ready. And what about this one? If it is dihydric phenol, look at here, or dihydric, yeah, here it will be like this, right? Just a moment, okay, yeah, it will be like this is dihydric, okay, dihydric. And if it is trihydric, okay, it will be trihydric. Okay, you can classify like that. It's very simple, right? If more than 2 or 3 is there, then you can easily call it as polyhydric alcohol, phenol or something like that. Okay, it's very simple. This classification is very simple. Now we are going to discuss the classification of ether. Either we can broadly classify into two. One is symmetric ether, another one is asymmetric ether or unsymmetric ether. Ready? So look at here. That's very simple. In ether, we already know the concept. Ether is ROR. Ready? ROR dash. I can take R dash for the to understand the difference. Ready? So look at here. If both R and R dash are equal, that means the both sides are equal, then we can call it as symmetric ether. Okay, we can simply call it as symmetric ether. Okay, symmetric ether. Ready? Is that okay for you? Okay, now if R and R dash is not equal, then we can call it as unsymmetric ether. Okay, unsymmetric ether. I'll give you some example for you guys. Okay, look at here. If you have a compound like CH3 or CH3. It will be symmetric either. Okay, and if it is CH3 or CH2 CH3, it is unsymmetric. Here both sides are different, right? Here we have methyl, here we have ethyl group. So both are different. So this one we can call it as symmetric ether. Okay, I'm just using SE, that is symmetric ether. Here it is unsymmetric ether. Okay, USE. USE means unsymmetric ether. I'm just shorting it. Okay, okay. There is no universal conversion like USE means unsymmetric ether. Not like that. Take it as okay. That's all from the part 1 of alcohol, phenol, and ether. I hope it's clear. Thank you.